Good day everyone. In today's video discussion, we are going to discuss about subroutine. Subroutines. Subroutines, aka routines, subprograms, procedure or function, may just be the most important building block of good code. They are the most basic kind of code abstraction. What is subroutine? A subroutine, also called a subprogram, is an abstraction of a process that is called. Subroutines are sequences of instructions that perform a specific task. It may return one or more values, but does not have to. It may be easier to think of them as mini programs within a large program. Subroutines consist of modules of code that performs different tasks. If these tasks are repeated throughout the program, they can be written as subroutines. The caller passes arguments to the subroutine which accept them as parameters. While the caller waits, the subroutine executes or evaluates its body, which may cause side effect to the global system state and optionally return result to the caller. A function returns a value or values and is called from within an expression. A procedure returns no values and is called in a statement, not an expression, but some language have no statement, only expression. The language use some mechanism like void context or employ a special return value like nil or parenthesis to make function look like procedure. A method is a subroutine defined on an object in an object-oriented context. Subroutine signatures. What is a signatures? A subroutine signatures specifies the number, order, names, modes, and types of its parameter and return values. Roughly speaking, something like this. Declaration specifies the subroutine name and its signature, and here is an example call. Note that in many languages, the parameters don't have types, nor does the return value. The set of modes differ between languages, but are usually things like in, out, alias, reference, and values. Signatures matching. The point of signatures is to distinguish legal calls from illegal calls. Languages differ widely in how they define whether or not a call matches a signature. Do the parameter names matter? Does the order matter? Do the types matter? Does it even make sense to put types restriction and parameters? Does the number of arguments in a call matter? What if we pass too few, too many? How do the modes affect what can and cannot be passed? Do the returns type matters? Can the subroutines be called as part of statement or must it be called in an expression? Can the subroutine be called as part of expression or must it be called in an statement? Hey, I want patterns for my parameters rather than specifying them directly. Very static languages have a rule like key equal in and the type of each must be compatible with the corresponding key, but many languages have many different rules. Parameter association. How do we know which argument goes with which parameter? Many answer to this question. Let's start with language without pattern. Positional and name association. Virtually, every language supports positional association. The first argument goes with the first parameter. The second argument goes with the second parameter, and so on. ADA allows both positional and name association. The order of the name arguments don't matter. You can mix the two styles, but the positional one must go first. Python is the same. It calls the name one's keyword argument. In Ruby, you mark the parameters that must be named with a colon. Overloading. With overloaded subroutines, the compiler has to figure out which subroutine is being called. This is called overload resolution. How to deal with ambiguity. Is the return type considered? What are the modes? How about the numbers of arguments? When variadic subroutines are in the mix, should we search in outer scopes even when subroutines of the same name are closer to the call? Should ambiguities be detected at the point of call or at the point of declaration? Default parameters. You fake them in Perl because of all the arguments are passed in the big list. Some languages have de facto defaults. If you don't call the subroutine with enough arguments, the missing parameters automatically get some kind of undefined or null value.
Variadic subroutines. A variadic subroutine can accept an arbitrary number of parameters. In Lisp, you make a function variadic by marking the last parameter with and rest. In Perl, all subroutines are variadic, since all arguments are collected into the array like this. In Java, you can mark the last parameter of a method with like this to mean that it is really an array and the caller can pass in a variable number of arguments without the clunkiness of putting them in an array. Python is similar. A parameter prefixed with like this collects the extra parameters into a list. With like this, the extras are collected into a dictionary. Here is an example from a Python tutorial. Patterns. In JavaScript, function declarations don't necessarily have patterns. They have patterns. JavaScript have both array patterns and object patterns. The ML languages do pattern matching pretty much just on constructors. Function returns. Function returns. How hard could it be to just return something? Again, there are so many questions. How many return values have a subroutine? Have open parentheses 0, 1, many, close parentheses. Perl, any number. In the ML family, exactly 1, close parentheses, to get 0, return unit. To get more, return a tuple. Most other languages, 0 or 1. What kinds of objects can and cannot be returned from a subroutine? Algo, 60 and Fortran. Scalar only o Pascal. Scalar or pointer only. Ada, 83C. anything but an actual function, though pointers to functions okay.
Common mechanism. People have identified a bunch of mechanisms over time. In constant, Kali can't write to the parameter. Out, Kali can't read the parameter. It just sends the value out at the end. In out, Kali can read and write parameter. Changes to parameter are reflected in the argument, but we don't know if the argument see the update during or only after the execution of the Kali. By value, argument value is copied to the parameter. Changes to the parameter are not reflected in the argument. By value or result, argument value copied in, parameter value copied out, and end of Kali. Aliasing, sharing, argument and parameter are one. Changes to parameter immediately are seen in the argument because, as was just mentioned, the argument and parameter are one. By reference, an implementation of aliasing through passing the address of the argument. By name, parameter is more or less a macro taking on the source code text of the argument. Michael's code made a nice summary. Implementation allowable operation on parameter can argument change aliasing. Generic subroutines. In statically typed language, how can we say that a parameter can be passed arguments from different types? In C++ and Ada, the compiler generates code for every instance of generic subroutine. In C++, each actual subroutine is implicitly generated with needed. But Ada, you have to implicitly instantiate.
Here's an example of a Java generic method. Subroutines as values, many times especially in event-driven systems such as GUIs, event-based servers, or asynchronous message handlers, we need to call subroutines indirectly. The actual subroutine to call is not known until runtime, so we need the subroutines to be values or at least the notion of a reference to a subroutine. In some languages, a subroutine S may be just another object like an integer, string, or list. So, we can ask this question. Number 1. Does S have a type, and if so, what is it? And what are the type equivalence and compatibility rules? Number 2. Can S be assigned to a variable? Number 3. Can S be passed as an argument to a subroutine? Number 4. Can S be returned from a subroutine? And number 5. Can we generate a new unnamed subroutine on the fly at runtime? In ML, LISP, Scheme, Haskell, Clojure, and other functional languages, then answer to all 5 questions and definitely yes
Other languages answer many of these questions no, but other might say the answer is technically not but allow reference to subroutines everywhere. Closure. If your language lets you, one, store subroutines as values and two, nest subroutines, then you can make closure. A closure is a subroutine that refers to variables defined in an enclosing scope. They are interesting when the enclosing scope itself is a function, because when the enclosing function goes out of scope, its local variables must be retained because instances of the inner function must still need them. This is both powerful, but you have to be careful not to fill up memory since a lot of stuff become ineligible for garbage collection. Subroutines as arguments. At first glance, passing subroutines as arguments doesn't appear to raise any scoping problem. However, what happens when you pass a subroutine which references non-local variables? Do we use the referencing environment that is in place when the subroutine is passed, or the one in place when the past subroutine is eventually called? Deep and shallow binding. Consider the following code from Scott's book, reported to JavaScript. The function in blue is defined in the context of the first activation of A in which I is 1 but is called from a context in which I is 2. Some languages will be defined to use one or other. We say the language uses deep binding if it uses bindings at time of definition, swallow binding if it uses bindings at time of call. Try some example in different languages. Thank you very much and God bless.